Hello, welcome to this meeting of the Science and Engineering Council. We're happy to have you here today and people also on the Zoom meeting here with us. Our monthly luncheons are held the second Wednesday of each month at noon, both in person and on Zoom. Our speakers focus on science and technology topics of current interest and include extended time for Q&A. Our outreach programs include STEM scholarships administered through the Scholarship Foundation of Santa Barbara. And I wanted to introduce board members who are here today. Bill Behringer is our treasurer. Carol is our executive assistant. I'm the programs chair. Mary Howe Grant is a board member. And do we have anybody else in that? I don't see anybody else. I don't see anybody else. Joseph is also a board member. And Joseph is also with Community West Bank, and we thank them for use of this room and the hybrid meeting setup. Subtitles are available in the Zoom session. If you choose show captions, you can type questions into the Zoom chat during the talk or ask them after the talk. And recordings of many of our past meetings are also available on our YouTube channel. You may have noticed in our recent emails that we've added a section near the end that lists related events around town. Our plan is to foster ongoing cooperation between Santa Barbara organizations related to events about science and engineering topics. For example, we'll be listing events hosted by Las Cumbres Observatory, Friends of the KITP, and the Santa Barbara Astronomical Unit. So be checking that section of our emails for the latest news. And also let me know if you have events you'd like to add to that calendar. Today, we'd like to highlight two upcoming events. The Santa Barbara South Coast Chamber of Commerce contacted me to let our attendees know about Techtopia, a panel of speakers telling the stories of some local tech companies, including Agilent, Curvature, Google Quantum AI, Kyocera, just next door, and Transform. This will be on November 15th at the LinkedIn office in Carpinteria. The Chamber is also planning a couple of events related to grid storage and microgrids in early 2024, which I know will be of interest to several of our members. This evening, Ventec, which was previously called MIT Enterprise Forum, is hosting a talk on the James Webb Space Telescope. And we have Kevin Riley from their board here to briefly introduce their speaker for that event.
Thank you, Kevin. Thank you. Pleasure to be here, and we are excited to be hosting Dr. Matthew Greenhouse tonight to talk about the James Webb Space Telescope.
Great. You want to just give a quick overview of what your topic will be for the...
Sure. I'm Matt Greenhouse. I'll be giving a soup to nuts overview of the Webb Space Telescope mission designed for a general public audience. So you don't have to know anything. You will understand everything I say.
Great. And what time is that and where?
So it's being held at the Cabrillo Pavilion from 5:30 to 7:30 this evening. If you want to register for tickets, go to ventec.org and you can still register for tonight's talk.
Great. Thank you.
Thank you.
As far as our upcoming meetings, on December 13th, Dr. Craig Prater, CTO of Photothermal Spectroscopy Corporation, will be speaking on shining a light on microplastics, providing tools for informed environmental action. Our email about that event will be going out to people on our mailing list. As always, feel free to contact me about particular topics or speakers you would like to suggest for future meetings. Our speaker today is Dr. Larry Martinez, Professor Emeritus of Political Science at Cal State Long Beach. Professor Martinez taught and researched the governance of cyberspace and outer space for over 30 years at Cal State Long Beach. After completing his PhD at UCSB, Dr. Martinez joined the U.S. Department of Commerce to participate in the policy process for issues of international trade in outer space and computer and telecommunications products and services. Dr. Martinez serves as the official observer for the International Institute of Space Law at meetings of the UN Committee for Peaceful Uses of Outer Space in Vienna. He's speaking to us today on ensuring the sustainability of outer space, orbital debris dilemmas. Welcome, Dr. Martinez.
Great, well, thank you very much. I feel a little bit out of place because this is the Science and Engineering Council of Santa Barbara, and I'm neither a scientist nor an engineer, but hopefully everything's going to work with the Zoom and so forth, and that a political scientist will be allowed then a little bit of speaking room here to illustrate the interdisciplinary nature of this huge problem that is now facing the world. And I'm very gratified to have Matt here in the audience. The JWST has been hit several times actually by objects, and so even 1 million miles from Earth doesn't put you out of harm's way. And so scientists have to do a very, very detailed risk analysis. And of course, what we're going to be talking about here is closer to home, just a few miles over our heads, as we contemplate almost on a weekly basis launches out of Vandenberg that my wife, Kathy Boggs, she and I can enjoy from our kitchen back door the views of launches out of Vandenberg. And so growing up in San Luis Obispo, I reckon I've seen in my lifetime over 100 launches, and at least. And so we're very lucky to be so positioned in the space race. Of course, in other respects as well, the lunar rover was designed here in Goleta, and the one of the aspects of this problem, and as a political scientist, what we're talking about here is a textbook classic example of what UCSB biology professor Garrett Hardin, in a science article in 1968, deemed the tragedy of the commons, which has been a recurrent theme throughout the literature of the social sciences as well as the natural sciences. And what we're looking at in terms of outer space is the classic tragedy of the commons problem, or otherwise known as a collective goods problem. And what I hope is that when you come away from this little discussion we're going to have here today, is that you will have a more nuanced view of this tragedy of the commons problem that space debris presents to us. And so if you have any questions at any time, please raise them. We don't have to wait till the end to discuss any points that my descriptions don't adequately fulfill the needs of the audience. So please speak up. So before we get started, any questions? Now, having taught on Zoom during the pandemic, I had multiple screens at home and was able to juxtaposition everything. Here I'm one screen, so please grant me a little bit of leeway as we reverse. Oh, okay, now sound. Okay, so hopefully this works. There we go. Okay, the question is, why is space debris a problem, and what are we going to do about it? And so this is starting at the very beginning. We'll be looking at how is outer space making space debris a big problem. And the reason why is that outer space is becoming the high ground for 21st century human civilization. Whoever controls the oceans controls world politics, is what a social scientist, historian, Tinder said many, many years ago, and about the oceans. Well, now the oceans have been replaced by outer space. And on February 24th, 2022, is that the Ukraine war broke out as Putin directed Russian forces over the border against Ukraine. But it really started in outer space with an attack on the Viasat satellite system. A code was sent through the Viasat satellite system, and it destroyed modems on the ground, as well as disrupted windmills in Germany. And so war now is in outer space. And this is another contributing cause of the problem of space debris. Then we'll be looking more nuanced. Why is space debris a problem? Is it really a problem? Or is it just something that you put into the cost of business, cost of doing business? And three, if it is a big problem and outer space is important, what is the international community doing to address this problem? And what are the likely, let's say, outcomes in the coming, let's say, 2 decades? Okay. Should go to the next page. Now, why isn't it going to the next page?
You put the arrow on the page.
Yeah. Oh no, I've been hacked. Okay. All right. Okay, first of all, we have to start at the very beginning because this is an issue that is presenting itself to many, many governments. And as we all know, being in the area of science and engineering and so forth, is that basically the public doesn't know anything about it. The public has no conception of what the radio spectrum is. The public has no perception that, for instance, the moon is a vacuum.
Didn't think
The
it'd be able to
level of
feel
scientific
the ground.
knowledge about outer space is so low is that it really presents a huge challenge to governments around the world and to commercial entities on how then to overcome this giant public ignorance about science and technology in order to overcome a lot of the resistance and bad policy making that is based on completely unrealistic, let's say, premises about what the science and technology. I'm often a radio talk show commentator on the Dave Congleton show on KBC in San Luis Obispo. And I remember walking into the minefield of 5G several years ago and how the public is convinced that 5G is a government plot to put thought control in our brains. And so this is the type of thing then that you have to deal with. Space debris all the more because you're dealing with outer space. You're actually dealing with rocket scientists. And so this is something that we have to always keep in mind, apart from the people here in this room. And I'm very, very, let's say, humbled because I'm in the presence of real experts in many of these fields, and a lot of people in this room know a lot more about their field than I do with respect then to outer space and technology and so forth. But for the general public, it's shaped largely by the media. And so what we're going to try to do here is go to this video. Everything works. Okay, here we go. This is from the Mexican director, Alfonso Cuarón. Alfonso Cuarón and I are about the same age. And he was struck as a child growing up in Mexico City because he saw the movie Doom. And Doomed was a, is it Doom? No, that's not, no, it's not Doomed. It's Stranded.
Stranded or something.
Oh, no, I forgot. It's the movie and it has Gregory Peck in it. Marooned. Yeah, not Doomed. Marooned. Doom is another video game. Yeah, and then there's Dune. Okay, he saw Marooned, and then he saw 2001: A Space Odyssey. And these are films that shaped a whole generation of people that were interested in outer space. And so let's see, get over to the share screen. And okay, this is from the film Gravity that won Academy Awards, and it came out in 2013. It was very, very interesting for me personally because in 2013, I attended the International Astronautical Congress. It was in Beijing, China. And if you've seen the movie, how does Sandra Bullock save herself? Chinese capsule. So she comes, re-enters with a Chinese capsule. And right there in Beijing, in the exhibition space, they had a Chinese capsule that had returned from space. So literally the same year that I saw this movie, I was in Beijing and saw the capsule that Sandra Bullock re-entered. Okay, this is the public view. This is Huaron is very, very accurate, and he makes in the speech of this scene a lot of very, very accurate statements about the cause of the disaster that is about to occur to George Clooney and Sandra Bullock. Are we hearing any sound?
Nope.
Select the share.
Oh, there's nobody saying that.
Matt, immediate return to explore. Repeat, immediate return to explore.
Copy. Explorer, prep airlock.
Airlock engaged, ready to receive.
Houston, elaborate.
Debris from the missile strike has caused a chain reaction, hitting other satellites and creating new debris. Traveling faster than a high-speed bullet up towards your altitude. Now copy.
Copy all. Put a bow on it, Dr. Stone.
I can't. The board is still initializing.
I'm not gonna ask you again.
1 second.
Not 1 second, now. Shut it down. That's an order.
Okay, I'm sorry. I'm sorry, I'm done. Kowalski, initiate emergency disconnect from the Hubble.
All right, Sharif, let's do this.
Roger, Matt.
Houston, update?
Well, we have a full-on chain reaction. It's been confirmed that it's the unintentional side effect of the Russians striking one of their own satellites.
They shut down their own satellite.
Right at disposal. Most likely a spy sat gone bad. Now it's shrapnel. Explorer ready to disengage HST.
Locks releasing in 3, 2, 1.
Explorer, new data coming through.
What's the blowback, Houston?
It's not good. Most of our systems are gone. Debris chain reaction is out of control and rapidly expanding. Multiple satellites are down and they keep on falling.
Define multiple satellites.
Most of them are gone. Telecommunication systems are dead. Expect a communication blackout at any moment.
Kowalski, visual of debris, 9 o'clock.
Half of North America just lost their Facebook.
Explorer, repeat. Expect a communication blackout at any moment.
Copy that, Houston.
Explorer, this is Kowalski confirming visual contact with debris. Debris is from a BSE sat. Repeat, I have...
Dr. Stone requesting faster transport.
We have to go, go,
Kennedy reports meteorological conditions. Don't go.
Houston, Explorer, copy. Explorer, Dr. Stone requesting faster transport to Bay Area. Explorer, do you copy?
Explorer, permission to retrieve Dr. Stone.
Your go, Kowalski. Houston, this is Explorer, copy.
All right.
We've lost Houston.
Oh,
We've lost Houston.
unstrap. Look, we need to get the hell out of here.
Need some
help there, man? No, don't wait for us.
Stuck!
Man down!
Houston, this
Man
is
down!
Explorer, copy. Houston, this is Explorer, copy. Kowalski, protect.
Explorer's been hit. Explorer's been hit. Astronaut is off structure. Dr. Stone is off structure. Dr. Stone, detach. You must detach. If you don't detach, that arm's gonna carry you too far. Listen to my voice. You need to focus. I'm losing visual of you. In a few seconds, I won't be able to track you. You need to detach. I can't see you anymore. Do it now. Houston, I've lost visual of Dr. Stone. Houston, I've lost visual of Dr. Stone.
Okay, now we're back. Okay, so you saw this little episode out of the beginning of the movie Gravity, and what it illustrates is the way in which a very conscientious filmmaker can present the issues of space interrupting the scientific technological work being conducted on the International Space Station, which is true. The International Space Station has to move itself out of the way of incoming debris almost on a bi-weekly basis on average. The astronauts oftentimes have to, if it's a large piece that is likely to be in the vicinity of the space station, they have to retreat to the Soyuz capsule, close the hatch in case there is a general depressurization. As well as one American astronaut unwittingly put himself into a much longer stay on the International Space Station because a piece of debris hit the Soyuz and it caused a coolant leak in the Soyuz, rendering the Soyuz rescue capsule unusable. And so due to the crew shifts that are constantly transitioned, instead of staying a couple months on the space station, this American astronaut found that he was staying almost a year on the International Space Station. And so this is an indication of the types of issues that are complicating large projects. And we have a scientist here from the JWST, and they are also dealing with the whole issue then because the hole that hit the JWS, please correct me if I'm wrong, that it was actually larger than what the prediction for a typical micrometeorite hit on the JWST was going to do.
When the JWST were hit by natural meteorites, we expected that and we designed.
Right. Okay, so why is outer space the high ground for 21st century? One, satellites are completely central to nuclear deterrence, and they've been that way ever since the 1960s. So both the superpowers developed very quickly following the orbiting of the first satellites, a way of doing reconnaissance. With infrared sensors, you're able to detect space launches, indicating the start of a nuclear war, for instance, or some kind of a rocket launch. Satellites, secondly, are central to 21st century economics. The infrastructure of the world is dependent now on GPS. It's dependent on the communication facilities set up by outer space communication links. At UCSB, I picked out a dissertation topic, which was how is the world going to allocate slots in the geostationary orbit? Because at that time, back in the 1970s into the 80s, is that all of the communication facilities were that were being positioned in outer space were largely going into the geostationary orbit, with an exception of the Soviets' Molina system that was in a high elliptical orbit, because when you look at the map, a great deal of the Soviet Union is at very high latitudes, and this is difficult to hit at the geostationary orbit of 22,300 miles, which makes a highly elliptical orbit much more, let's say, usable. Today, the hot area is low orbit. And the reason why low orbit is great is because of the fact that you can have a very small handset with very low power levels and be able to access satellites such as Starlink. The problem with geostationary satellites, they're out 22,300 miles, and the handsets, or whatever communication device you want to use, if you want to have enough bandwidth to have a customer pleasing experience, it means that you have to have a high power level, and you're putting an antenna right next to your brain at microwave frequencies. Not recommended if you value your mental health in the long term.
You also have major latency, right? Like
That's
you're going to be a half a second by the time you get up and down on your communication.
Yeah, it's the bane of romantic relationships, because you have these long pauses, and so it disjoints a conversation. And so one of the big problems was, what do you do about the latency? Now, with really fast computers, a half-second latency is a lot of computer operations. And so that introduces an inefficiency to geostationary satellites. So today, many more are going into the lower Earth orbits, as well as, and then finally, for measuring climate change, land use, natural resources, pollution levels, air pollution, ocean pollution, is that satellites and remote sensing technologies are intrinsic to the way in which we are, let's say, detecting these natural environmental phenomena. And so this is very, very central then. Okay, why is space debris a problem? Space debris is one aspect of what you can call space weather, or the environment around the Earth. That is to say, the Earth is a very, very complex system that goes through outer space in its orbit around the sun. And we are very directly affected by solar activity. For instance, the amateur radio operators are very happy because we're hitting the peak of solar activity, which energizes the ionosphere to a much higher extent than normal, and it reflects radio waves very well. And so for the next few years, this increase in solar activity is very welcomed by the amateur radio operators. It is not welcomed by Elon Musk, because Elon Musk and Starlink decided to launch a package of 20-some Starlink satellites, but they didn't check the weather report for space. And they put the satellites up in a low orbit. There was a large eruption off the sun, and the solar wind that hits the Earth actually increases the friction in low Earth orbit to the extent that they lost 20 satellites. They put them up, and within a few hours, the 20 satellites had re-entered and burned up in the atmosphere. And so you have to be cognizant of space weather. Secondly, space objects can damage and or injure human beings or human infrastructure on Earth. For instance, the Carrington event is a very big event that occurred in the 19th century, where a huge solar eruption was detected along telegraph lines, so you actually had sparking on telegraph keys. This is also the space objects. If we go into away from space weather and just talk about space objects, is that space objects can hit things in Earth orbit. They can hit things on the surface of the Earth. They can hit things in the air. There was about 6 weeks ago a tank that washed up on a beach in Australia. And the tank was a propulsion tank, most likely from an Indian booster rocket that was boosted up. It fell into the ocean, and this tank is floating there, and it would present then a hindrance or a threat to the safety of oceanic navigation and transits. And so you can have space debris pose a problem long after a space launch from floating debris in the ocean. And this large tank that washed up in Australia is an example of that. We are somewhat like lawyers following the ambulance, but it is inevitable that there will be a human injury or death during a spacewalk caused by space debris, much like the film showed. We already know that the space station, the space shuttle, all objects that are up there are being hit. Space is big, but if you have a human being in a spacesuit, they don't have the same kind of protection around them, and that inevitably there's going to be a death or injury to an astronaut caused by space debris. It also poses a real threat then to the safe operation or the reliable operation of satellites that we are dependent on, and that future generations may face an unusable orbital realm due to what's called the Kessler syndrome. Kessler is a scientist who put forward a prediction that space debris begets space debris, because up in outer space, one collision creating debris creates debris that hits other debris, creating more debris. And you have then a progression, a hockey stick going up of debris. And this could render whole orbital regions unusable in the future. And so for coming generations, this is the classic tragedy of the commons problem again, is what do we do about it? Yeah. Any questions? Yes, sir. Yep.
When you say orbital regions, are you talking about the, elevation away from Earth, like that whole sphere? Or are you talking about something else?
Yeah, we're talking about different, that's a very good question, because you have then the legal problem. The legal problem, there's no legal definition of outer space. There's no boundary that is legally set. And so at what point is an object in outer space? Because once you go into outer space, your legal status changes according to the outer space treaties.
Well, I'm just asking about the physical, like
Right. Then
Elon Musk. Where do you park your, like, what orbit are you going to put your next 1,000?
right, and then you go up and what's called LEO, so low Earth orbital region, which are the first few 100 kilometers up. This is where the International Space Station, Starlink are. Then you go medium Earth orbit, which goes out a couple thousand kilometers. And then you go into the much higher orbital realms, which is the geostationary. And that's 22,000 miles out. So you have generally three big realms: LEO, MEO, LEO.
Yeah, I'm just asking, if you got a bunch of crap flying around out there in the LEO realm, it's not like you're going to take every LEO satellite out, right? I mean, you got
No, space is big.
Billions of dollars invested in that stuff. So
Space is big. But here's the big idea to keep in mind, is that the farther out you are, the longer the junk stays there. So at GEO, 22,300 miles out, the objects put at that altitude will be there forever. They're never coming down. I mean, maybe in a billion years.
So do they stay geostationary as well? So
Well, they'll
just
drift.
using orbital slots.
They will drift, and eventually they will their altitude would change. The farther you come down, the more stuff they hit. And so as you come down, for instance, the International Space Station is at around 400 kilometers. So it has to constantly reboost because its large solar panels and everything present drag. And so it will re-enter because there is so much resistance to that huge surface area that it has. So the farther you are down, the less time you can remain in orbit because of all this stuff that you hit. Space weather, other particles, there's all sorts of stuff. It also depends where you are, which plane or orbital plane you're actually going in, because there are some orbital planes that are more exposed to this than others. So for instance, I was talking to a flight attendant on this Finnish air jet I came back on Sunday from Helsinki, and we were talking about in Solar Max, they actually don't want pregnant women flying over the North Atlantic at high latitudes because every passenger on that plane got the equivalent of a chest X-ray of radiation. And so if you're a flight attendant and you're thinking about getting pregnant, you actually don't want to fly on polar flights, and especially now during the Solar Max, because you're encountering more radiation. Okay, let's go. Naturally occurring space debris. All right, just like what the James Webb got hit with is a micrometeorite that originated somewhere, we don't know where, but it hit it. This is 10 years ago in the year 2013 in Western Siberia. And this is a small asteroid that re-entered the Earth completely unknown to all telescopes on Earth. No one knew this thing was coming. It hit And the explosive power was the equivalent of several Hiroshima bombs. It exploded in relatively high atmosphere because it's coming in at 40 to 50,000 miles an hour, hits the thicker part of the atmosphere and is instantly vaporized in a type of an explosion. This blew out windows. But what do you really see when you look at this? What do you really see? The potential for misidentification. Is this an attack on Russia? Did someone put a sneak attack on Russia? And so what space debris poses is the potential for citing a mistake, that somebody doesn't know that this is coming. This hits with explosive power of several nuclear weapons, and it just takes one nervous finger in a bad political situation to really ruin your day. And so naturally occurring space debris happens all the time. The Earth every day is hit by there are thousands of tons of debris that are encountering the Earth's atmosphere. They re-enter. We don't see them. They're so small. They're just dust. But for instance, the meteor showers that oftentimes you'll have in the summer is when the Earth goes through a debris cloud left from a comet. And so this is seen as a meteor shower, but this is naturally occurring space debris. Debris in this sense is, I define it as any object in the orbital region around Earth that no one controls. So if you don't control it, then it's not a space object that someone is directing. It has it has rockets on it, so you can direct then its trajectory to some extent. In this case, debris is something that no one can control. Human-caused space debris is what the main focus is, because we do have some control over it. This is from the late 1970s. The United States had taken its last moon rocket, the Saturn V, converted the upper stage into Skylab, which was a space station. We put several crews on Skylab, and then we sort of forgot about it. And its orbit, it was in a low Earth orbit. It started to come in, and no one had a good way of saving it. They could have put some sort of space tug on it to push it back up to a higher altitude, but it came in, and so here you have on the left Der Spiegel, and it says Skylab crashes to Earth. Is it a danger for Mainz? In other words, is it going to hit a city on Earth? And on the right, it's here comes Skylab, Time Magazine, 10 years after the moonwalk, and you have already this third stage of a Saturn V re-entering, where it won't all burn up. It's coming down, and Skylab left a debris field in the outback of Australia, which didn't hurt any kangaroos or anyone else, as far as we can tell. Okay. The congested orbital region. So here's where, in the previous question, it's a very good question. So when people think of space debris and the problem of space debris, the first thing they normally think of is the geostationary orbit. This is the circular orbit, 22,300 miles above the equator, where if a satellite is placed in this orbit, it appears geostationary, that is motionless to a person on the ground. And this is a great advantage because you can have millions of subscribers with their rooftop dishes, and you only have to install the dish once, and the satellite is going to remain in that position all the time. And so you just take the dish, put it on the roof, point it up on the satellite, and you have a subscriber that's going to be able to get television. And this is also a big plus then for the countries that want to use communication satellites in order to broadcast over 1/3 of the Earth's surface, or provide other communication facilities and networks. The problem is that in terms of your business plan, you want to have the most subscribers able to see your satellite in the geo, which means that there are certain places in the geo that are far more valuable than others. And you can see some of these, for instance, with more satellites in certain positions, because you're able to see both the Pacific and the Indian Ocean at the same time, where you can see the Atlantic and the Pacific at the same time, or the Indian and the Pacific at the same time. The other parts of the geo are less valuable because you're not able to see as many populated areas. And this created a crowding problem so that the developing countries back in the 1970s were afraid that they were going to be locked out of the geo, and that the rich countries were going to take all the preferred slots. Now, a satellite lasts, in the old days, a satellite would last around 5, 7, 10 years or so. Then the technology got better, they lasted longer. And now the satellites could be used up to 20, 25 years in the geo. What can we do to preserve the usability of the geostationary orbit? And here's where, in order to prevent a dead satellite being uncontrollable, is that you boost it up into the higher graveyard orbit around 300 kilometers farther up. And this graveyard orbit takes it out of the probability that it will become an uncontrollable piece of space junk that will hit an operating satellite in the geostationary orbit and disable it. And so this is where you have to have then this international rule by which countries operating these satellites will, at the end of the satellite's life, they have to forego millions of dollars of income using these satellites at that position. And they have to shorten the operating lifetime of the satellite by several months in order to use that station keeping fuel to boost it up into the graveyard orbit. And that's the tragedy. Yeah.
So my understanding is that the geo belt, you're basically exactly offsetting gravity versus centrifugal force, right? That's what keeps it in that orbital slot with the least amount of space keeping fuel usage. Is that a correct assumption?
Well, that's one of the other characteristics of the geostationary orbit is that that isn't quite accurate. What the geostationary orbit is all about is that the object there appears motionless to the user on the Earth. And so if you're precisely on this equatorial plane and you place the satellite precisely in that slot on the geostationary orbit, is that it doesn't move relative to the user on the Earth. Now, there have been proposals to build a space elevator, and you can put a space elevator and have a counterweight, that counters the weight of the elevator, but the counterweight, and you could put these in the geo. Yeah, you could put them in the geo.
So I guess more or less, I think you confirmed what I said. So if you push this up further away from Earth, then you're going to offset the
no, if you push it up, then the satellite starts moving relative to the user on Earth.
In a lag, right? So so then I guess everything is just in the same, in that hula hoop, ring is just everything's lagging at the same rate. They all get pushed up to about the same altitude.
It's all driven by the business plan. The business plan is make it as cheap as possible for everyone on Earth. And the cheapest way to set it up on Earth is you don't have to move your antenna. And that's the beauty of the geo. That's why it's the favored real estate of outer space is the geo.
And why is the retirement orbit higher rather than lower?
You could put it lower. If you put it lower, the satellites will move. I don't know exactly why they don't put it lower.
It'll come down to everybody
higher.
else. Right. Some
Yeah,
other-
you could go either way. You just don't want it in the geostationary orbit itself. You want it in a place where the satellites are going to be drifting, but they're not going to drift into a perfectly healthy functioning satellite.
What's the dimension of the orbit?
The orbit, yeah, it's 700 kilometers between each degree of spacing in the orbit. And you can co-locate to within, you can put several satellites at a like that chart shows, is that there are multiple satellites at a particular position in the orbit, because with precise station keeping, they can maintain their spacing. And as long as the satellites have directional antennas or are using different radio frequency bands, then everybody is copacetic. But you get really bad problems in GEO, and this happened. You had a solar event where the sun spews out a lot of charged particles. They hit the Earth's upper atmosphere, magnetic fields, and so forth. And it wiped out the receiver on a Galaxy 15 geostationary TV broadcast satellite. So that the receiver was gone, you couldn't control it, but the transmitter stayed on. So the transmitter is spewing out really strong radio frequency energy off its directional antenna, but the satellite is uncontrolled. It's just drifting around. So everybody else around the Galaxy 15 satellite had to move their satellites out of the way because this thing is drifting. Well, it went on like this for several months until what's known as the equinox. So when the Earth, back in the autumnal or the spring equinox, when it's perfectly aligned to the sun and the equatorial line is in a direct line, is that the geostationary satellites go into a shadow of the Earth. The shadow of the Earth was fantastic because it depleted the batteries on the satellite Galaxy 15 and it rebooted itself. And when it rebooted, I mean, what do you do when you have a computer problem, right? You reboot it. Well, that's what the satellite did. It rebooted and they got the receiver back. And so they were able then to put the satellite back in operation. But in the meantime, it was a piece of debris that was throwing off all this radio energy that was interfering with other networks, other satellites. It was one of the more interesting cases of what we call zombie sat. Okay, increased orbital congestion due to commercial entities. And what you're seeing here is the Elon Musk effect and Starlink. So these are the launches, payload launch into 200 kilometers and below 1,750 kilometers. And orange here, yellow, is the commercial launches. And look at what happens. Everything is government defense, 1960s, 70s, a few commercial starting in the year 2000, and then everything takes off. And so we have now outer space, which is previously dominated by governmental satellites, are now dominated in terms of numbers by commercial satellites. This is the successful disposal in LEO, and this is how obedient are these commercial operators to actually disposing of their satellites correctly. And so this is 90% compliance with the law. And what you see is that compliance is actually quite low. And this indicates part of the political problem in telling countries what to do with their satellite systems. Okay, this is from last week, so I'm ruthless in taking pictures of great slides. This is Raoul Fauché of the European Space Agency, who gave a great lecture and here's what that slide says. So this is the current debris status situation, according to the European Space Agency. We have right now 7,500 operating satellites and around 6,200 tons of debris in outer space. There are about 2,040 discarded rocket stages and around 2,800 dead satellites currently in orbit. There are about 21,000 other debris objects in orbit. About 26,000 are trackable. So the larger the piece, the more likely it is that ground-based radars can track it. There are 36,500 objects larger than 10 centimeters. That's about 5 inches. There are 1 million objects up there between 10 centimeters and 1 centimeter, and 130 million objects between 1 centimeter and 1 millimeter. Okay, so 1 centimeter is about this much, and that can wipe out your satellite. So the trajectories are so fast at these orbital planes and so forth, is that there are literally an uncountable, I mean, that's an estimate, 130 million. But it indicates the scope of the problem, and it's only getting worse. Now, the good news is that everyone's aware of it now, because things are getting hit, and so we're very likely to be looking at what the international community response is going to be. Yes, sir.
So jet propulsion, in you know, the whole concept of it is you're propelling something out, which is the fuel. So you're propelling out a bunch of massive molecules in a gaseous form. Do those molecules create any issues out there?
You mean, well, it all depends what molecules you're talking about.
Just from jet propulsion, right? So whatever it is coming out, the jet, right?
Because here's the deal, is that the big problem they have in the creation of debris with propulsion is that there's currently no real rule that compels a launch company or a launching state from putting up a rocket stage, goes into orbit, and it just sits there, and it goes in orbit, and nobody moves it or anything. And after a while, the fuels inside can mix in bad ways, and they explode. And so then you create debris out of the leftover fuel in these tanks. Some of the fuels are what are known as hypergolic. Hypergolic fuels ignite on contact with each other. But for instance, hydrazine is one of the most dangerous and poisonous materials known to mankind. And for instance, when the space shuttle landed, at Edwards or at Cape Canaveral, the first thing they had to do was bring in a giant fan to fan away any hydrazine clouds that may have formed, because when the shuttle's coming in, it's using its thrusters in order to position itself as it comes in, and they want to make sure that the astronauts are not going to be poisoned by the hydrazine cloud that could, from just the ambient breeze on the runway as the space shuttle lands. So they have to set up this giant fan to blow all that stuff away from the astronauts as they emerge from the shuttle. This was a big problem in Vandenberg. They had a Titan 34D that blew up on launch, and a huge hydrazine cloud started drifting south, and they had a national park ranger on San Miguel Island, and that guy was in danger of getting hit with the hydrazine cloud.
So I think it's probably water comes out, or what? It's hydrogen and oxygen that's being combined.
Depends on the rocket.
Okay, but that's at least some rockets.
Well, the most environmentally friendly rocket is a liquid oxygen, liquid hydrogen rocket, and the exhaust is water. I mean, that's pretty benign.
So my question, I think the answer is no, but I just want to be sure.
Okay, yeah, sorry.
You didn't get to it, which is the gas, are those gas molecules a problem from a debris standpoint? The gas molecules, not that if they explode and cause metal.
You're talking about, no, they're just going to disperse in space.
And so hitting that at 1 million miles an hour or whatever, some things are traveling up.
Unless no, but it's a problem for the astronauts or any entity that wants to go and recover a piece of debris like a rocket stage. So the fuel left on the stage or any outgassing of that fuel, if you're right in the vicinity and suddenly there's a leak in that tank, you're an astronaut, and the hydrazine squirts out and is hitting you, you're in trouble.
That's a different issue than I'm asking.
Right. Yeah. Yeah. What you're talking is the gaseous. Yeah. Outer space is big and it's just going to diffuse. Yeah. Other questions? Yes, sir.
Recently read that China is not complying with international requirements with its stages and fuel tanks. It's dropping them indiscriminately.
Mm-hmm.
Are they going to sign up to an agreement or?
Good question. Last year, they had to shut down air travel over Spain because a re-entering Chinese booster was coming in through Spanish airspace. Okay, so the international community response, and here's where we get into sort of the alphabet soup. The lead agency, I would say, is the International Telecommunication Union, because they have been around longer than anyone else in terms of assigning a orbital position and the radio frequencies for any object launched in the outer space. And so the ITU, which is an intergovernmental organization founded in 1865 in Geneva, it has taken over many of the functions of regulating Earth's orbits. And they have the rule that says if you're in the geostationary orbit, you are to put your satellite into a gray orbit. And so that doesn't present a danger to the satellites in the geo. Second organization is the United Nations Office of Outer Space Affairs, located in Vienna, and the Committee on Peaceful Uses of Outer Space, known as COPUOS. And that's what I go to every June, representing the International Institute of Space Law. About 100 countries belong to COPUOS, and many intergovernmental organizations and non-governmental organizations. And so the ITU is really involved with the regulation of telecommunications. And so insofar as all satellites have to use telecommunications to carry out their missions, there's a very, very tight coherence between what the ITU does and satellite regulation. COPUOS is more talking about what are the big, larger legal issues. For instance, who are you going to sue if you get hit? And this then is the big problem for space debris in a legal sense. Next are the group of government experts that are also looking into these problems. And we're going to be talking a little bit about, for instance, the militarization of outer space, but also the whole idea then of the what can countries do in order to boost confidence that other countries are pursuing best practices. And the example of the Chinese booster is an indication that there's a wide disparity between countries on this. Finally, you have the IADC, which is the Interagency Space Debris Coordination Committee. And this is also a UN agency, and they are developing what can be some of the best practices. I was at COPUOS when they passed the long-term sustainability guidelines for outer space, and that really put into writing then what are the best practices for averting space debris problems, and yet that had not the power of law. It's only a guideline. It's a voluntary guideline that they hope that countries then will pursue. The International Telecommunication Union is located in Geneva, and this is where decisions worth trillions of dollars are made. Trillions and trillions. Versus COPUOS, which is a debating society. They just sit there and they debate. So you have really the two lead agencies, ITU and COPUOS, in terms of the space debris issue. Okay, then you have non-governmental organizations. Yes, sir.
That's non-governmental.
No, those are governmental.
ITU is?
Yes, ITU is the governmental institution, the longest continuously operating intergovernmental organization in the world since 1865. Yeah, this is the International Telegraph Union originally. Okay, non-governmental organizations, the Space Data Association was a voluntary consortium set up to exchange data about satellite orbits so that if there's a conjunction means a problem, means two objects are going to come too close to each other. And so the Space Data Association was a way by which the satellite operators, and especially the commercial operators, would pool their information and be able to predict then when is there likely to be a problem where somebody's going to have to move their satellite out of the way. Okay. Yes.
So do we have problems with that data, just like we do with tracking ships and fluid going places that they don't want to be known to be going?
Great question. The problem is no military establishment wants to reveal how good their radars are. And so the Space Data Association was always at disadvantage because it's a private voluntary organization, and they're reliant then on data coming in from the actual satellite operators themselves, who consider their data proprietary, and they would also be more highly accurate if they were able to get the best possible military tracking data. No military is going to reveal the full extent of their radar tracking capabilities. And so this raises the uncomfortable legal question. If the United States Air Force or Space Force was able to use its tracking and to see that there was going to be a conjunction, but they didn't tell anybody, would the United States be liable? Yes.
Did the Space Data Association predict the collision of the Iridium and Cosmos satellites?
No. And that's one of the big examples of a perfectly healthy Iridium satellite getting hit with a dead Russian satellite.
Just when did the Space Data Association begin?
It began right around the year 2000.
Oh, okay. So the Iridium was 2009, I guess.
Yeah, it was later. As a non-governmental organization, one of the leading is the Secure World Foundation. They're headquartered in Boulder, Colorado. They have offices in Washington and Brussels, and they regularly have big international meetings of experts on space sustainability, and are one of the examples of non-governmental organizations taking a leading role. Major cause of space debris is space warfare. And what we have here is a change in warfare away from the terrestrial areas into now outer space. And so kinetic war, which was based upon the Westphalian system of state sovereignty, and you win wars by blowing things up and destroying infrastructure. Now this is going into outer space, and you have countries conducting anti-satellite tests. And these anti-satellite tests is to show that a country is capable of defending itself against satellites. The bad part of it is that if you blow up a satellite in Earth orbit, you're creating a debris cloud. The next is cyber conflict. And this is the topic of the conference I was at in Tallinn, Estonia last week, which is the industrialization of the internet and satellites and so forth, something like Starlink and other satellite systems up there. And the example I gave you of the attack on Viasat on the first day of the Ukraine war means that you can disable satellites by hacking them and essentially create more debris that is a dead, uncontrollable satellite by hacking into the satellite, changing a little bit of code on the operating system of the satellite. You can make the satellite incapable of charging its battery and it's dead. Okay, and then you're creating more debris. You're creating more uncontrollable satellites, because what you want is to have satellites controllable, and then at the end of their life, they, in a controlled way, they re-enter and burn up. And then they don't pose a problem to people or things. But cyber can disable huge numbers of satellites, and these would then become debris. So space warfare plays a role in all this. Satellites are totally, let's say, necessary. This is a commercial satellite system that is showing you the battlefields of Ukraine based on the jamming of GPS. So it can measure how each of these sides may be trying to jam the GPS, because if you jam the GPS, you can't target your missiles, you can't target your tanks, you can't target your troops. And so this is a commercial company selling commercialized battlefield data. And so wouldn't somebody love to disable that satellite? Let's say if you're Russia, wouldn't you get your hackers out there and let's disable then this commercial satellite?
The drones all seem to have a dome on the top. Wouldn't they point their GPS up so that they can't be jammed from the bottom?
Well, I mean, there are all sorts of ways of trying to maintain in highly classified ways your GPS and other locational data. GPS is not the only system out there. You have GLONASS, you have the Chinese system, the Beidou system. So you have now multiple system receivers and techniques for jamming as well as highly secure GPS. But this is one of the most hotly contested areas of technology as the United States and other countries try to develop jam-proof GPS satellites. They're very weak signals. Yeah, the signals are very weak because you're way out there. You're thousands of kilometers out. Russian counterspace activities in the Ukrainian war and UN governance. On the left is a calendar showing various Russian activities during the Ukraine war that have affected the operation of satellite systems, the jamming of a commercial satellite system, Starlink, attempts to jam Starlink. And so it just shows you now this new configuration of interests that we see between commercial satellites and in a battlefield. The anti-satellite tests, these are the countries conducting anti-satellite tests in orbit. So Russia twice, 2015, 2021, China 2007, the United States in 2008, and India in 2019. And the United States tests, the United States said that, well, we tested our anti-satellite weapon, but we did it in a very, it was a retired satellite and it was a very low altitude, which meant that the debris cloud was very quickly re-entered. And so it didn't pose a danger. The Russian, China, and Indian tests were at higher altitudes, which means that the debris cloud from some of these tests have rendered large orbital realms almost unusable. So what we're looking at here, space debris is one aspect of this reconfiguring of world power. And so space is becoming the high ground of the 21st century. And space debris in terms of what's known as, and here's the new acronym for you all to become familiar with, is SSA. So if you want to sound cool, you say SSA, which is Space Situational Awareness. And space situational awareness is your ability then to defend your satellites against threats. So we know that countries are developing satellites that will come up to other satellites, and they are able then to monitor these satellites and snip off little parts if they so desire and disable the satellite. I don't think it's the most effective way because you have to launch and you have to get a satellite up there. But we have regularly a classified mission that lands here at Vandenberg called the XB-37. It would spend months up in orbit, and it's reusable like a space shuttle type device. And we don't know what it's doing up there. But what is true is that we're looking at a reconfiguration of world power. My argument is that when you combine outer space with cyberspace, is that we're looking at one of the greatest transformations in world power ever due to technology since the Middle Ages and the Westphalian system. But what we're looking at here is cyber warfare being applied in outer space. And what we're uncomfortably finding out is that many satellites, remember, some of these are very old satellites too, is that they are intrinsically vulnerable. Remember, commercial operators are going to try to maximize their profits. And how many of you are happy with the cybersecurity of your credit reporting agency? Anybody here happy? Okay. Okay, they're pursuing basically a strategy of surveillance capitalism, and surveillance capitalism requires a porous operating system because you have to be able to track the user in order to sell that data to advertisers. Well, the same thing for outer space is that if you're a commercial operator, you're going to try to get as much money out of the system as possible and spending the least amount on what you consider expenses. And commercial operations consider cybersecurity as an expense, not a part of the investment. And so this is one of the cultural problems that we see now in terms of addressing these problems.
Yeah. If you do everything right, nothing happens, and that's hard to get money for.
That's right. And how do you prove a negative? How do you prove a negative? So just because everything looks okay, does it mean then that it's actually working? So we have then, how do we solve this? Long-term externality, which is cyber conflict and space situational awareness. So cyber war in space, I spoke about. Space crime is now becoming something that people are looking specifically at in terms of the cyber hacking of satellites. No one has ever been charged. No one has ever been brought to trial. The weaponization of space debris, you could disable the GPS satellites if you're North Korea. You just send your cheap rocket up there to the GPS altitude with a large amount of nails in it or something and disperse them at that orbital altitude. And eventually they'll start hitting satellites. So it's like the poor countries' way to address the power asymmetries in the world due to the vulnerability of the satellites. The hard law approach is a regulatory enforcement. Hard law means it's a treaty, it's written down, and it's compulsory. So if a country ratifies a treaty, it has to, under the laws of international politics and so forth, they have to follow through on that obligation. And so the hard law approach is, and regulatory enforcement, we have this month, we can celebrate that the FCC levied its first fine on a miscreant out there in orbit. It was Dish Network, and Dish Network had a Echo Star satellite, and they did not put it properly into the graveyard orbit, and they were fined $150,000. First time a fine has ever been assessed for space debris. Okay.
Who do they pay? Who gets the money?
The FCC. Well, we taxpayers. We get it. Don't you feel? Yeah.
We just didn't know what it was.
Did you say FCC?
Yes,
Federal
FCC. Yeah, FCC. Okay, soft law approach means these are voluntary agreements, much like what you see in the UN. And this is largely because of the predominance of commercial entities. And each country wanting to preserve its economic self-interest and of its companies, they don't want to divulge proprietary information that would be otherwise required under a hard law treaty. And so you have soft law approaches, and these are, for instance, the code of conduct or best practices. And so the long-term sustainability guidelines are all voluntary, and yet they represent best practices But we're not going to see really anything happen, I predict, until an astronaut dies. Until you see something really bad happen out there, for instance, to the International Space Station or to an astronaut, and you will then see the liability convention brought into effect. The only other case that mentions the liability convention, which was ratified and brought into effect in 1972, was the crash of Cosmos 954 in Canada in 1978. Cosmos 954, Soviet Union lost control, but this satellite, a spy satellite, had a nuclear power source on board. Nuclear power source crashes into Canada and spews nuclear material over a wide area of Canada to the west of Hudson Bay. Of course, Canada calls their best friend the United States. We send the nuclear forensic people up there, and we get valuable information about nuclear reactors in the Soviet Union and their role in the space program based upon that nuclear fuel. Canada then gave the Soviet Union a bill for $12 million for the cleanup, and the Soviet Union paid them $6 million. And so there's a shortfall of $6 million, and this is they wrote up a protocol, and they mentioned the liability convention, but they never actually invoked it in terms of forcing the Soviet Union to pay the full $12 million. So that's where we are right now. And so I'll just conclude there. Thank you very much. And we can have a discussion and questions. Yes, sir.
So I'm still trying to wrap my head around this concept that you've mentioned multiple times of orbital realm being resulting in being useless, like dangerous to use. So it makes sense to me, that term makes sense to me in the geo belt, but I'm still trying to wrap my head around it in the LEO realm, right? Like the LEO realm, as far as I'm aware, they're not following a repeated path, right? They're in some, it's not random, but it's not repeated. So it's like the entire shell, right?
Yeah.
That spherical shell. Are you saying that could be be useless, like certain altitudes?
It's the tragedy of the commons, because right now, if you go to the ITU, and the ITU has this procedure for avoiding conflict between satellite systems. And so all these various entities, countries and companies are coming in there. And right now the ITU has a backlog of registrations for 300,000 satellites in low Earth orbit. Because you have now not just Starlink, that's just the beginnings. The big problem, for instance, are astronomers. I was sitting in Vienna next to the guy who was in charge of a program that the International Astronomical Union. They have a big problem because all these low Earth orbiting satellites are very close to the ground. They're not very far away. They reflect sunlight, at sunrise, sunset. And the telescope operators want to know, when is a satellite going to pass within our visible range so that we can turn off our telescope? Because the reflections back from these low Earth orbiting satellites is so intense, it can damage actually the sensors on the telescopes. And so this is a problem. And then if there is significant numbers of accidents of people not, in best practices bringing their satellites down, is that you could have so much debris up there that you would have trouble launching even. Because in the low Earth orbit, the debris will come down sooner, but the rule up to now has been 25 years. So if you put something up there, it stops operating, it's supposed to re-enter within 25 years. Way too long. That was an old rule. Now the FCC is saying to US satellite operators, 5 years. Okay, so you put a satellite up, 5 years. They're trying to develop technologies for bringing the satellites down. the very small flecks of paint and stuff that are up there, you know, several hundred kilometers, you can actually push out of the way using a high-powered laser on the ground. So if you know where this stuff is, you can actually sort of move it using a laser. The other is that when you have CubeSats, and there are literally thousands of CubeSats up there, very small satellites, if you put up a little sail at the end of its lifetime, the sail will be hit by all that solar material, and it will actually degrade the orbit eventually and bring it in. So there are techniques to do that can help ameliorate it. But if the Kessler syndrome is correct, is that you could reach a point of no return, where certain altitudes in the low Earth orbit realm are unusable because there's so much debris in there. And so this is the thing we want to avoid. And so we'll see what happens. Yeah.
No, so just reading one of the ideas that if you had a tractor beam, right, you could go up there and pull some of this stuff, which is of course science fiction, except it turns out it's not science fiction. That there is now a technology that uses a high energy electron beam that you get electrostatic difference in charges, and you can slowly bring something, gather something up and bring it in. But slowly meaning like a month, apparently. You have to hit this thing with a charge for a month. So it's not practical now, but if you heard of that technology or is there anything, you know, does that have legs? Is that going to be effective? Do you think something like that?
Yeah, I just saw a blurb about that. So for the tractor beam. The other is really, see, the big problem are all these little pieces that you can't really detect of paint. And they hit you, you're in trouble. But these can be pushed, as I was saying, by lasers. Or there are other companies that are proposing big nets. They would put a satellite up, it'd have a big net, and it would go and collect debris in the orbit using a giant net. You can throw a net over a dead satellite and then reel it in, and then you can, with a retro rocket burn, degrade its orbit so that it re-enters. So, yeah, it comes down to how much do you want to pay? What's it worth to you?
Do we have any questions from the Zoom?
I was wondering if there's any plans for, and if World War III comes up, I'm sure that the first thing that will happen is that all sides will take out everybody else's satellites.
Yeah. Well, World War III, I mean,
there will be an immense number of debris after that. If we ever go back, I guess.
Well, again, the most likely targets are anything that would, let's say, tend to be a decapitation strike at your opponent. If your opponent has a certain reliance on certain satellite systems, that's what you would hit first. And so, but the cheapest way to incapacitate satellites is through a cyber attack.
Okay.
Not kinetic. Kinetic is messy. And this is where everyone today, I mean, in the field, in this conference I just went to in Tallinn and so forth, is everyone, as much as everyone's concerned about cyber war on Earth, is now cyber war in space is becoming very, very, very salient in the world agenda. There was a German X-ray telescope satellite that was hacked into, and the hackers took over control of the satellite. Okay, created a piece of debris just by hacking in. It's called Rosat, and it's one of the more prominent examples of what would be possible in World War III, which would be, how do you incapacitate your opponent's satellites? Well, Russia just showed us. You put a command through the Viasat satellite system, which is geostationary, and then it comes down to the ground segment, and the kill codes actually incapacitate the chips on the routers and the modems on the ground. And that's the way that you decapitate your opponent's command control and communication facilities, your CQI.
Takes a pretty good rocket to kinetically attack a geo satellite, anyhow.
And it's visible.
Yeah.
Because you have all these satellites up there that had infrared sensors, and they're geared to detect whenever there's a heat source. That heat source is a rocket launch. So unless you can launch a rocket without generating heat, then it's pretty visible.
Fusion rocket.
Yeah.
Spin.
So
Spin orbit.
Well, it's 1:30 when we usually break, so I guess we can break and questions in the room and that sort of thing.
and everybody should go to the JWST event this evening.
Yep, right.
Thank you.
Yeah.